Hey guys, welcome to my channel. I'm LeetCode. If you guys are new here, I pretty much do LeetCode style questions and I explain things in the simplest way possible. Today we have a pretty amazing problem, guys, that I'm pretty excited about. Yeah, let's go ahead and read the problem statement, guys. So the problem's called longest uh, Univalue path, right? So it says, given the root of a binary tree, return the length of the longest path where each node in the path has the same value, right? It says this path may or may not pass through the root, right? It says the length of the path between two nodes is represented by the number of edges between them, right? It's a pretty good thing that it told us that fact, right? Pretty important, guys. Um, this is a pretty good problem, guys. It's gonna teach us a lot of things, about different, ways we could traverse the tree and be able to solve it, guys. So I like this a lot. I like it a lot. So you can see the example given, right? Pretty much they're saying that they want us to find the length of the longest path, right? Where each node in the path, right, have the same value, guys. So you can see the longest path, right, where all the nodes have the same value is what, guys? It's gonna be this one, guys. It's gonna be, this one, 1, 5, 5, 5, right? This length of this path is 2, right? Two edges, guys. So that's why the length of it is 2, guys. Very important, guys. So for this one, right? See, the longest path is one. This one goes. So I'm saying it said it may or may not pass through the root, right? Which is a very important case. I have to make sure you guys understand about this problem, guys. So it may not pass through the root, right? So because of that, it could go this way, right? It could go from the left side, pass through this root node, and then go on to the right side as well, right? But when it can be extended, what I'm saying is a very good thing, right? So it's not only, it can either go from the left side or the right side. It can go, kind of like that, right? So it's a we did a prop similar to that, right? Which involves some kind of the diameter, right? The diameter of a tree, I think, right? Or we said that may not press best. So it's going to be kind of the same approach, kind of the same thing, guys, that we're going to be doing here pretty much, right? Uh, yeah, so pretty much the way that we can see this problem, guys, how can we solve it? What's the kind of the intuition, right? We're gonna have to solve it like that, guys. So we can how can we solve it, right? So we did a problem similar to this, right? Called Univalue, right? Something's gonna pop up, right? Where we had to check if the whole tree was like some kind of univalued or something like that, right? So check that out. That's pretty good as well. So that gives you some kind of idea how to solve this problem. But this one's a little bit unique, right? So we know how to so we know how to calculate path, right? I'm saying we know how to do that, but we only need to calculate the path where all the nodes, right, are the same, guys. They have to be the same, right? I'm saying. So see for this case, right, this path is not a good path, right? It's not a valid path. So we're not gonna account for it because it's not the 4 is not the same as its parent node, right? So therefore, it doesn't matter, right? And then just like this case again, right? 1 is not the same as 4, yeah, it's parent node, so this is not a valid path at all, right? But you see for this example, right, we're given 4, this 4, right, is the same as this 4 because I'm saying the same value. So um, because of that, we're gonna account for that path, right? So we're gonna account for it, and then we check also the right? We're gonna count with the L also accounts for it, and then it concludes that say, okay, then I can say that this is the longest path, right, that I have, right? Yeah, so that's kind of how we're gonna solve it, guys. So pretty much the way we're gonna do it, guys, we're gonna process the node in a bottom up um, fashion, right? So pretty much we're gonna pretty much go um, down, right? And then process those nodes first and then work our way up. God, we're gonna do a DFS, right? We're gonna use recursion for that. Pretty much we're gonna go down, right? And then we're gonna process our nodes first, right? We're gonna process the left side and our right side, right? First, right? Every time. And then as we're going back up the recursive column, right, we're going to check, guys. And so the root node, after obtaining the answer from the left side and also the right side, right, is going to do a couple checks, guys, to see um, how we can extend the current running path of our um, left subtree and right subtree, guys. So, and then I told you guys we also gonna have to do one other thing, guys. We also have to every node gonna calculate the path, right? The longest path at every node, right? So Yeah, so it's a so we can, I told you guys this case we can go through a node, right? So we're gonna, so pretty much gonna be the path of the left side from a node's left side and the plus the right path of the right side. I'm gonna show you guys exactly why. Don't worry, it might be a little bit confusing now, but bear with me. Everything's gonna become clear to you guys, right? So we see that so yeah, the thoughts that I've been saying right now, right? So pretty much, we're gonna, after we check the left side, we're gonna check, is our is our left, right? Is our left side, is it the left child node, right? Is it the same as the root node, right? That called it, right? If it's the same, guys, we're gonna pretty much we're gonna account for that path, right? So we're gonna account for that edge. So we're gonna do one plus that node's value, right? No, one plus the the length of the subtree, right? The length of the longest path that it had so far, right? So this example is a pretty good one. So 4, so pretty much we go here, right? So I told let's do a quick run through. So we do 1 goes down, 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 down. 4, right? 4 hits a base case, so we get 0, 0. So um the length of the longest one is going to be 0, right? For that particular case, right? 0. So now 0, so 4 is going to return 0 to 4, right? So now 4 is going to decide, should I extend the current path, right? Should I add myself to it, right? So it checks if is it the same value as the left child node, right? If it's the same value, guys, right? Then we're gonna say, okay, cool. So I'm gonna add +1 to account for that edge that connects us together, right? So we're gonna account for that. So we put +1, right? So now the path on the, you know what I'm saying, is 1 right now, right? On the left side, right? So also the right, the 4 also check the right side. So it returns 0, right? And then it's gonna check as well, right? 1 plus 0 to account for the path on the right side, right? Only account for on the right side, guys. So very, 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 very important, guys. So it's the same, right? So now we got 1 from the left. So we got 1 from the left side and 1 from the right side, right? And now what we're going to do, guys, that's going to pretty much make it. So we're going to calculate the longest path, right? So we're going to add the two that we made, right? The left side plus the right side, guys. So that's going to give us a length of 1 plus 1 gives us a length of 2, guys, which is this path right there, guys, right? This is exactly what we're doing, guys. So with this, I'm gonna show you guys, yeah, as you can see, it's the same thing. So 5 calls 4, calls 1, right? Call 1, 1 checks, returns 0, and then 4 sees that on 1 is not the same value as 4, right? So it's not, so it doesn't account for it, right? It doesn't account for that edge right there, right? For that, yeah. So it says, all right, cool. So it's 0 from the left side. All right, cool. It checks the right side, same thing, 0, right? Cool. And then 4 can only return 0 to the thing, right? Because none of its subtrees um or Univalue, right, were the same. So it only can return 0, right? To say, hey, I only got myself, so I'll return 0, right? So, and then 5 calls, right? 5 checks is not the same as 4. So I'm not gonna account for that edge because we're not the same. So I only need to worry about that path, right? That path is gonna be 0 because it says the path, the longest path where each node at the same value, right? So that's what we're doing that, guys. We only accounting for paths where the value of the parent node like the same, right? That's the only path we're gonna keep building, gonna worry about, right? So this case, right, pretty good one, right? So pretty much it goes left, there's nothing on the left, so 0, right? It goes right, 5 checks left, right, no, no, and then 5 returns 0, right? Say, cool, I don't get any children, so I can only return 0 to you, right? See if you can extend yourself, right, for the same value now, right? So 5, see, oh yeah, we are the same value, so I'm gonna do +1 to account for that edge right there, guys. And then 5 can only return 1, right? It returns 1 to 5, right? And then 5 is gonna do, cool. So so we're the same value. I'm gonna do +1 plus the 1 that you return to me, right? Which is 2, right? That's why you return 2, guys. So that's kind of the whole gist of this problem, guys. So it's a very, very good problem. It's a very good way of traversing the trees, guys. So pretty good problem. A lot of difficult problems can be solved by using this kind of approach where you visit all your journals first, right? And you wait for the answers to those subcalls, and then you do particular checks accordingly, guys. So yeah, it's a very good way of solving this problem, guys. So pretty much we're gonna have some kind of instance variable, guys, because they said that the path may or may not pass through the root, guys. So whenever I hear that, right, I always do it like that, guys. You know what I'm saying, I have some kind of instance variable, and then I return it at the end, right? Because we're gonna, at every node, right, we're gonna calculate, guys. I told you we're gonna calculate um, the longest path, right, that we have, right? So yeah, because it may not pass through the root. That's why we need to do that, right? We need to have some kind of that kind of variable because to help us calculate, guys. So all right, and also keep track of the maximum so far, right? Saying because it may not pass through the root. Same thing as the diameter question, right? The same thing. That's why we do it like that, right? So okay, int helper. So we're using a helper function, guys, because we are keeping it consistent with all the tree problems that we've done on this channel before. If you guys haven't seen that, I highly suggest you guys go check it out. It will really, really mean a lot to me. So go check it out and let me know what I'm saying. Yeah, so root, so base case, right? Root is going to null. Then we return, guys, 0, right? That's what we said. That's what we're going to do. So, and then, guys, we're going to go to the left, right? And we're going to do root. So I'm tripping. So do helper. It's going to be root that left. So we go on the left side. We got left traverse, what I'm saying. We go to the right as well. And then we do, yeah, we go to the right. And then, yeah. And then we're going to do a couple checks, guys, which is very important, right? So we check if the root that left is not null, right? Right? If it's not null, right? We're going to do a couple things right there, right? And then, sure you guys can see clearly, all right? So if root that left, that val, right, equals to the root, right, the parent node that called on the left side, right? If it's the same, then we're going to do some kind of clever things right there, guys. So, all right, sure it's up. Yep, it's good now. So, yeah, we go to the, so yeah, so we need to check. So we need to calculate the path, um, left path. So let me see, so the left side, right, and the right side. So I'm gonna tell you guys exactly where I have these variables, guys. Very important, right? It's can be confusing right now. So the left side. So pretty much we do the left, right? We go check our left side, we go check our right side, right? We're gonna get some kind of answers, right? And then based on those answers, right, we're gonna see can we extend, guys, those answers, right? I'm saying, can we extend by adding ourselves to it, right? By doing +1 to account for that connection, right? So, and then we just do, so pretty much for the left side, right? Right? The left side is going to be 1 plus, right? Whatever the left side was, right? Which is very, very important, guys, right? And it's only going to hit that, right? If they're the same value. If they're not the same value, right? Then the left side is going to stay 0, right? Because I can't extend it any further, which is very, very important key concept for you guys to understand for this problem, right? Why I'm doing it like that, right? So we calculate the left side, right? See, can we extend it? If we can extend it, which is the case for this one, right? So 4 return 0, right? So 4 checks, is it the same? Yeah, it's the same. So it's going to do a left side, it's left side, right? It's going to be 1 plus 0, right? To account for that edge, right? Which is very, very important, guys. And we're going to do the same, guys. I'm saying for the right side, right? This is a pretty clever way of traversing and doing operations on those kind of tree problems, guys. So a lot of problems have kind of the same kind of setup, right? We'll be doing a lot of those. I know it can be confusing, but let me know if I did a pretty decent job, guys, and then give me some feedback and how you guys want me to explain it more. Yeah. So yeah, after we do that, guys, you know what I'm saying, we got a couple stuff we need to do. So what are we gonna do, guys? We're gonna do so what's next? We're gonna calculate, guys. I told you guys every node we're gonna calculate the maximum, right? So we're gonna pretty much max is equal to maximum so far that we have, or the right side, right, plus the left side, right, that we just calculated right there, right? They would have been updated if the left side, the left node, right, child node is the same, right? And I would have extended by 1, right? Whatever value that I got from the left side, and what I'm saying, and whatever I got from the right side would have been updated as well, right? 1 plus the value on the right side as well, right? Same. Yeah. So after we do that, man, we're in good shape. We just return, guys, the maximum out of those two, right? The left side, because we're trying to calculate the path, guys. So we need to choose one or the other. You know what I'm saying? Very, very important, right? So you see, it's either the left side we're going to return or the right side, right? Not both. not the addition of those two. No, we did right side plus left side because it says the path it can may or may not pass through the root, and it can go this way as well, right? You can go from you can start from the left side and end up at the right side, passing through that whatever root node and going to that side, right? So that's why we're doing this, right? Sees what this means right there, right? So we see for this example, we see a one, and then we see a two, right? So the length of this path is two, guys, amount of edges, right, that we have here. Yeah, looks pretty good, man. It's a lot of code. I mean, not really. Hopefully you guys are able to understand the overall thought process. This can be kind of confusing, guys. So yeah, let's press submit. Let's see if we pass all these test cases, guys. No, awesome. We're going to pass all the test cases, guys. So I want to thank you guys for taking the time to watch this video, guys. If you guys found value, make sure to give me a like, guys. I would appreciate that like. If you guys are new here, make sure to subscribe to the channel because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next one.